All right, so in the previous video, we kind of showed how taking a Y connected source, and instead of looking at the voltage between one of the lines and the neutral, we look at the voltage between two lines, we get a much larger amplitude and a little bit of a phase shift, right? Precisely √3 larger. And so what's interesting about the delta connected source is that really what we always have is we have three sinusoidal sources just like this, but the configuration can be different. And so what you may have noticed is that I don't see the neutral here. So you might be wondering where the neutral is. And I think that that's a good question. And so what I want to show you is that what this delta connected source really is. I'm going to write here delta connected, and I'm going to write it in quotations for a reason. Really, all that the delta connected source is it's a Y connected source, just like this, the standard old three-phase Y connected source, but we're just looking at the voltages between the lines. We're not looking at the voltages from line to neutral. We're looking at the voltage from A to B, then we're looking at the voltage from B to C, and then we're looking at the voltage from C to A. And the way that the book draws it, right, is they draw it like this to indicate that those are the voltages that they want you to care about, but then they expect you to understand or memorize that this VAB is already √3 larger than this this voltage here, which we kind of derived in the previous video. But I want to show you that if I draw, a Y connected source here with a neutral in the middle. So I'm again, this is point A, obviously. This is point B, and this is point C. And I'll call this my neutral. Put a source here. I should definitely be doing this in a different color. So let me just highlight everything I've done already and just make it gray or something, a really light gray. Okay. And I connect it just like this. And I call this VA neutral, I call this VB neutral, and I call this VC neutral, right? That is exactly what I have, right, in the previous case. This right here, this Y connected source, is the same as this Y connected source. And the only difference is that here I've chosen to, instead of measuring voltages and basically looking at the voltage from A to the neutral, B to the neutral, C to the neutral, right? I'm looking at voltages from A to B. That's just the way that they've drawn this delta connected source. So really what I could do is I could delete these. Actually, you know what? Let me leave them and just make a copy of this so that that's even more clear. I'll resize this one a little bit and I'll rotate it. Make it a little smaller and make it flat. And let me create a copy of this just to show that these two things are equivalent. Paste this here. And if I were to just delete this source here, delete this source here, and delete the source here, what am I left with? Well, I'm left with my original Y connected source, but I'm measuring the voltage difference from VA to VB instead of from VA to V neutral, right? I'm taking this voltage here, which is VA, and this voltage here, which is VB, and we already proved that VA to neutral minus VB to neutral was equal to VA minus VB, which we know is just VAB. And the same goes for VBC and VCA. And so I think it is important to note that the delta connected source is really just a different way of looking at the Y connected source. Okay? That's a really important thing to realize, I think. That this is just another way of looking at the Y connected source and a different way of basically using it as a source. It's just instead of, and this is all going to come into making even more sense when we actually start connecting a load, which we haven't done yet, because ultimately the difference is when I connect a load, right? If I connect my load between VA and V neutral, my load is going to see 170 volts angle 0. But if I connect my load between VA and VB, my load is going to see 294.45 angle 30, right? So the same load connected here versus connected here is going to see two very different voltages. And that's why this is important. It's important to keep these connections in mind when we start analyzing circuits. Right now, we're literally just looking at the sources. We haven't even connected any resistors, any inductors, any capacitors, nothing. We're just looking at the sources to get an understanding of these voltages, because it's really important that when we look at the circuits that we're analyzing and we have, you know, a load here, we need to recognize, oh, that load is connected from A to B. So I need to remember that the voltage is VAB, not VAN or not VBN, because it's going to make a big difference depending on what you're given for the problem. The problem might give you, you know, VAN, it might give you VBN, and then it might connect a load right here and ask you to find the current through it. And if you think that you're going to use VAN or VBN to find this current, you're going to get it wrong, because the voltage across that load is VAB, right? So hopefully that makes sense. I really hope that that's clear, and that's the whole point of me doing this, is just to prepare you for the problems that we're going to be seeing, because it really makes a huge difference to note what kind of connection you're going to have across your load when you go to measure currents. Because this whole time in this class, right, we've been looking at circuits, we've been analyzing the voltages and the currents. We did that in EE 220. That's still the whole point here. But the motivation for these lectures and these videos is just to prime you for when we see the types of loads that we're going to be seeing, and we note, okay, if I connect a resistor here, I know that the voltage across it is VAB, right? If I connect a resistor here, I know that the voltage across it is VAC. If I connect a resistor here, the voltage across it is VAN, right? And so when we're going to go and solve these circuits and I ask you, you know, what's the current through this resistor, you're going to say, oh, okay, that's pretty easy. I know that the voltage is just going to be this point minus this point, which seems to be VB minus VC. So the voltage there is going to be VBC. And then I just take VBC divided by my resistance, and that gives me I, because I know Ohm's law, right? So this is all, it's not new stuff. It's really just a scary new way of looking at stuff with three sources, and there's going to be three loads and yada, yada, yada. So without me, blabbering any more about this, let's go ahead and end this video. And what do I have in the next video? Okay, in the next video, we're going to start talking about three-phase loads, okay? So I'm going to go ahead and end this video. We'll look at some three-phase loads, and then hopefully pretty soon we'll be doing some example problems, all right? So I'm going to end this video right here.